Yes, very good evening, my dear friends, and a warm welcome to this session. And I am Rushi Joshi. I will be discussing a topic of strength of material, a very important topic, my dear friends, that is stresses on oblique plane and subsequently the Mohr circle, how to draw the Mohr circle and all. So, my dear friends, please inform me. I am as I audible clearly to all of you. Yes, my dear friends, am I audible? Yes, very good evening. Imtiaz, how are you? Very good evening to all of you. आवाज सुनाई दे रही है क्लियरली? Okay, Soumitra. So, my dear friends, a warm welcome to this session on India's largest online live learning platform, my dear friend, by Gradeup Super. So, my dear friends, very fastly, please like this video, share and subscribe with your friends, my dear friends, also, so that they will be benefited with these classes which I am taking on the Gradeup GATE YouTube channel, my dear friends, which is the midnight series GATE qualifier series going on, my dear friends. All the topmost faculties are taking the subjects of their expertise, my dear friends, to have a revision part of the complete syllabus of mechanical engineering, my dear friends. So, very good evening. Yes, Venkat Reddy. Very good evening. Jai Hind, Bharat. Okay. So, my dear friends, before I start this session, I would just like to introduce myself. My name is Rushi Joshi. I have got around 16 plus years of experience in training aspirants preparing for competitive exams. I have mentored more than 25,000 plus engineers across India. This is my GATE score in the year 2002. Engineering mechanics, strength of material, and machine design are the subject of my expertise, my dear friends. That I deal for the students preparing for competitive exam. Yes, Bharat, I am also from Hyderabad. Good. Okay, Bharat, you are from Hayatnagar. I am from Gandhinagar, near to Ashok Nagar, my dear friends. Very good evening, Karthik. How are you? So, once again, I welcome you all on this session. So, my dear friends, can you tell me what do you mean by oblique plane and what is the importance of that oblique plane, my dear friends, before I start this session? So, before yesterday's PDF not sent. It is on Telegram channel, my dear friends. It is on Telegram channel. You can take it from there. Yeah, PDF for both the PDFs I will send today. Yesterday's and today's class I will send it today. So, my dear friends, before I start this session, let me tell you about the stresses, different types of stresses which are there. So, the first is uniaxial stress, as I told you yesterday, a single direction stress which is applied on this cross sectional, my dear friends. Biaxial stress, you see, sigma 1 is the maximum principal stress, sigma 2 is the minimum principal stress. When I talk about a three-dimension problem, my dear friends, sigma 1, sigma 2 and sigma 3 are the three stresses which are acting. And when I talk about the isotropic stress, means it is similar in all the three directions, that is sigma, 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 sigma and sigma. Means your sigma 1 is equal to sigma, 2 is equal to sigma 3 which is equal to sigma, and this type of stress we call it as isotropic stress. So, my dear friends, our interest is oblique plane stresses. What do you mean by oblique plane stresses? The stresses which are at some angle other than 0 degree and 90 degree is called as oblique plane, my dear friend. The plane which are at some angle theta degree other than 0 and 90 is called as oblique plane, and the stresses on that plane are called as oblique plane, my dear friends. Very good. So, my dear friends, one more type of stress is called as hydrostatic pressure, where P hydrostatic is rho GH Rho is the density of the fluid, G is the gravity, and D is the depth, my dear friends. You see that this is the pressure given by the fluid, that is your Px is equal to Py is equal to Pz, my dear friends, and which is equal to P, and the corresponding stresses sigma x is equal to sigma y is equal to sigma z, which is equal to sigma, my dear friends, which is equal to minus of P. Same is the case hydrostatic stress. So it is equal to minus of the pressure which is developed. It is equal to minus of the pressure which is developed, my dear friends. Is it clear now? So this is what is the hydrostatic stress which are developed. Now let's see what do you mean by oblique plane stresses. So my dear friend, when I talk about a component, when I talk about a three-dimensional problem or a two-dimensional problem, my dear friend, when I talk about a two-dimensional problem, so you see that when I am talking about this, let sigma x is acting in this direction and the effect of sigma x on the oblique plane. So if I consider a plane which is inclined at an angle theta degree to vertical, this plane P is called as oblique plane. Oblique plane. So obviously because of the sigma x, you see that on oblique plane you will be getting one normal stress sigma normal and one shear stress tau which is acting, my dear friends, and these stresses are called as oblique plane stresses, my dear friends. These stresses are called as oblique plane stresses. Is it clear to everybody? Yes, Srinivas Chakravarti, I will send the PDFs of yesterday's and today. Don't worry about that, my dear friends. Both the class PDF I will send it. So what do you mean by principal, my dear friends? Principal planes. Yes, can anybody tell me what do you mean by principal planes? The planes on which the shear stress value is equal to 0. So already I told you that this is subjected to one normal and one shear. If tau is equal to 0, then the planes are principal. Planes are principal. So the leftover stress are called as principal stress, my dear friends. So if the planes has got zero shear stress, so there is no shear stress, my dear friends, and that type of planes are called as principal. Hence the stresses are called as, the stresses on that plane are principal stresses. Denoted by sigma 1 and sigma 2. So my dear friend, please keep in mind that when you apply sigma x, you get one sigma normal, one tau. When you apply sigma y, you get one sigma normal, one tau. And when you apply tau xy, you get one sigma normal and one tau, my dear friends. So if you see that all this tau which is applied are becoming 0, then that planes are called as principal planes. The associated stresses on that plane are called as principal stresses. So these are applied stresses. These are induced stresses inside the body. Induced stresses. Is it clear now? So if tau is equal to 0, we get sigma 1 and sigma 2 are the principal stresses, my dear friends. If tau value is equal to 0, then we see that we get two stresses, sigma 1 and sigma 2. Is it clear to all of you, my dear friends? Is this clear? Very good. So let's proceed and see what is the value of the normal stress on an oblique plane inclined at an angle theta degree to the vertical. So my dear friend, there are two methods by which we can find out the stresses on the oblique plane. One is the analytical method and one is the graphical method, that is by Mohr circle. Mohr circle. Is it clear now? That is by Mohr circle, my dear friends. So initially we will talk with only one dimension problem, that when sigma x is applied, what is the value of the normal and the shear stress on a plane inclined at an angle theta degree to the vertical. So what is the value of sigma normal? What is the value of tau, my dear friend, is my question. So I know that the plane which is associated and sigma x is acting is called as, is on the cross sectional area A. Is it clear now? So when I consider the oblique plane, I cannot take directly sigma A, I should take px, which is equal to sigma x into A, because the area associated with sigma x is different and oblique plane area is different. So this is called as oblique plane, and the area of this oblique plane is A naught. So if this is inclined at an angle theta degree to vertical, my dear friends, you know that you will be getting two components. One is P normal, one is P tangential. P normal and P tangential, and this angle is called as theta, my dear friends. This angle is called as theta. So because of the normal, I will be getting sigma normal, which is equal to P normal divided by the oblique plane area, and shear, that is equal to P tangential divided by the oblique plane area. So my dear friends, can you tell me what is the value of P normal? P normal is equal to Px cos of theta, which is equal to sigma x into A cos theta, and this is equal to Px sin theta, which comes out to be sigma x into A sin theta. And if this area is A and this is oblique plane area, can you tell me what is the value of A naught? Yes, my dear friends, what is the value of A naught? So cos of theta is equal to adjacent side is A upon A naught. So A naught is equal to A upon cos theta. Is it clear? So my dear friend, when I substitute this will become sigma x into A cos theta upon A upon cos theta. So the answer comes out to be sigma x cos square theta is called as sigma normal. So my dear friend, when you apply sigma x in x direction, you get sigma x cos square theta on the plane inclined at an angle theta degree to the vertical, and your shear will become sigma x into A sin theta upon A upon cos theta, which can be written as the shear stress induced is equal to sigma x by 2 sine of 2 theta, my dear friend. These are the two important formulas by which we can find out the normal and the shear on plane P, oblique plane P. So my dear friends, in order to have sigma normal maximum, and that value is equal to sigma x at cos square theta is equal to 1, implies that theta is equal to 0 degree. Means this is the plane where it is 0. So on this plane you will be getting maximum normal, and tau at 0 degree is equal to sigma x by 2 sine 0, and the answer comes out to be 0. And since tau is 0, we call this as principal stress. Is it clear now? We call this one as principal stress. Yes, Anand, about shear center also I will take into consideration. I will also take into consideration about the shear center. No need to worry. Now, my dear friends, this tau is maximum. This tau is maximum, which is equal to half of the normal at sine of 2 theta is equal to 1. Means at theta is equal to 45 degree and 135 degree, we get shear maximum, and the planes are called as shear planes. Is it clear to everybody? The planes are called as shear planes. Venkatesh, why you taken x-axis cos theta and y-axis sin theta? Which is x-axis cos theta? Venkatesh, which cos theta you are talking about? See here, this is px, this is px. It will have two components, one perpendicular to the plane, one down the plane. Since plane is inclined at an angle theta degree to the vertical, the normal to the plane will be inclined at an angle theta degree to the horizontal. Is it clear now? Venkatesh, are you talking about this theta only or some other cos theta and sin theta? Yes, come on my dear friends. I am seeing that very few people have shared it. Like the button. Yes, my dear friends, please don't forget to subscribe this video, my dear friends, with your friends and share this video with your friends also. Yes, come on, my dear friends. Yes, Venkatesh, is it clear? If it is clear, let's proceed for the next topic, where I will be considering sigma y. Very good. So, my dear friends, now suppose if there is sigma y and sigma x both are acting, right? So, I will take only sigma y. I will take only sigma y and then we'll add up both. We'll take only sigma y and we'll add up both. Maximum वाला केस रिपीट करना है. I will just tell you. I will just tell you. Don't worry. So my dear friends, now when I consider sigma y, but before that let me tell you about this maximum. So what is this maximum? This will be maximum sigma normal maximum is equal to at cos square theta is equal to 1 implies that theta is equal to 0 degree. So when cos square theta is equal to 1 is maximum, hence the answer will be sigma x. So at 0 degree to the vertical, you see that you will get maximum normal. Is it clear, Imtiaz? And shear maximum and tau maximum will be equal to at sine of 2 theta is equal to 1. So implies that theta is equal to 45 degree and 135 degree, which are the shear plane, and the answer is half of the normal stress. So from this, my dear friends, you can see this. Is it clear now? Imtiaz, is it clear? Let's proceed when sigma y is acting. So my dear friend, when sigma y is acting and you see that this area is not known to us and this area is not known to us, so you see that the amount of sigma y which is acting here will give you py, and this py is equal to sigma y multiplied with area. What is the area associated here? The area for this will be AC into 1. So it is AC into 1 is the area, because I don't know the area. Right? Since I don't know the area, I am taking the area as AC into 1 is this area. Is it clear now? this area I have taken. Now you see that we have got two components of this py. This py will be having two components. As the plane is inclined at an angle theta degree to the vertical, it will have two components, one along the plane called as py cos of theta, and other one is p normal, and this is p tangential. This is equal to py sin theta, and this is equal to py cos of theta. Is it clear now? So you get the normal stress, which is equal to P normal divided by oblique plane area, which is equal to Py is called as sigma y into AC into 1 sin theta upon oblique plane area. What is the oblique plane area? This is AC. So this is AB into 1. AB into 1. So from this I will be getting it as sigma y AC by AB. AC by AB is called as what? Sin theta into sin theta, and this will become sigma y sin square theta. This will become sigma y sin square theta. So sigma normal is maximum, which is equal to sigma y at sin square theta is equal to 1, implies that theta is equal to 90 degree. So when the plane is inclined at 90 degree, you will get the maximum normal stress. So previously we got it at 0 degree, now at 90 degree with a maximum. So tau, which is equal to P tangential divided by the oblique plane area, which can be written as sigma y AC into 1 cos theta upon AB into 1, and this will become sigma y by 2 sin 2 theta. This is tau. So my dear friend, your tau will be maximum, which is equal to half of the normal at sin of 2 theta is equal to 1, implies that theta is equal to 45 degree and 135 degree. Is it clear? So my dear friends, you see that on two planes. So on two planes at theta is equal to 0 degree and 90 degree, your sigma normal is maximum, and tau on plane P, tau on this plane is equal to 0. Hence these two are called as principal. Is it clear now? And at theta is equal to 45 degree and 135 degree, your shear is maximum, your tau max is equal to half of the normal, my dear friends, half of the normal. So there are chances that it may fail because of normal or it may base because of shear. So if I consider one element, the element may fail because of normal or because of shear also. On normal means at 0 degree and 90 degree. That two are the critical planes. So we should satisfy that two planes. And second is your tau max. Tau max is at 45 degree. So we should focus on 45 degree also, because the material may fail because of shear. So let me explain you the concept very clearly here. So the maximum normal is equal to sigma x at 0 degree and sigma y at 90 degree. Is it clear now? When sigma x and sigma y are acting, means if the material to be satisfied, it should satisfy sigma x and sigma y, which is maximum of these two, and your tau max is equal to sigma x by 2, or which is also equal to sigma y by 2 at 45 degree and 135 degree, my dear friend. Is it clear now? So this is half of the normal, I can call it as. So while selecting the material, compulsory your sigma value should be equal to your sigma normal maximum. Your sigma y should be equal to sigma normal maximum, and your shear strength tau, which is equal to shear strength of the material, should be equal to at least half of this. If you don't have this, it is going to fail. Means if I consider an element having sigma y as 200 MPa, compulsory the capacity of the material in shear should be 100 MPa. If the capacity of the material is not 100 and it is 75 only, then it is going to fail, my dear friend, at 76 MPa. Is it clear now? So compulsory your shear should be half of the normal. Yes, my dear friend, area changes. No need to worry about the areas. No need to worry about the area, my dear friend. I am talking about the oblique plane. So here in this, in sigma normal, you have got just sigma x cos square theta at, right, only when this is applied, and your sigma normal, this is on this plane, and sigma normal when sigma y is applied, sigma y sin square theta, which is also in this direction. So this is sigma normal, this is sigma normal. So when I club these two, both sigma x and sigma y, when apply sigma x and sigma y, now tell me what is the value of sigma normal. Now tell me what is the value of sigma normal. So sigma normal on plane P is equal to sigma x cos square theta plus sigma y sin square theta. Is it clear now? Because both are acting in one direction, and the shear on plane P is equal to sigma x by 2 sin 2 theta minus sigma y by 2 sin 2 theta. So my dear friend, it will become sigma x minus sigma y by 2 sin of 2 theta. Is it clear now? So for this problem, this is the case. Is this clear? So when both are acting, this is what we need to consider. Yes, everybody. Yes, my dear friends. I am seeing very less people has liked this video, my dear friends. So please, if you are enjoying the session, please click the like button. Don't forget to press the bell icon, my dear friends. Share with your friends also. Is this clear now? Now let's see here. I am explaining you here. When sigma x is acting, I know that on an oblique plane inclined at an angle theta degree to the vertical, you have got sigma normal, which is equal to sigma x cos square theta, and tau in downward direction, which is equal to sigma x by 2 sin 2 theta. This is plane P, right? And when sigma y is acting, this is for sigma x, and for sigma y on an oblique plane P, you get sigma normal and shear in upward direction. So sigma normal is equal to sigma x sin square theta, and tau is equal to sigma y by 2 sin of 2 theta. Is it clear now? Right? So this normal and this normal are in one direction. So total normal when sigma x and sigma y are applied, we get sigma normal as sigma x cos square theta plus sigma y sin square theta, because both are acting in one direction. And when I take downward here, this will become sigma x by 2 sin 2 theta minus sigma y by 2 sin 2 theta, my dear friend. This is called as tau. Is it okay to all of you now? Is this clear to everybody? So your sigma normal is equal to sigma x cos square theta plus sigma y sin square theta, and tau is equal to sigma x by 2 sin sigma x minus sigma y by 2 sin of 2 theta. Is it clear? Vikas Yadav, is it clear now? Very good, my dear friends. Very good. So let's see if there is a shear which is acting. So my dear friend, when shear is acting here like this, when shear is acting here on the body, this is tau xy, this is also tau xy. What is the effect of shear on an oblique plane? So my dear friends, you have got two values of this shear, one a vertical shear, one a horizontal shear. So when I take vertical shear, this is P xy, or I can write down this as xy and yx, or P vertical, and one is P horizontal. So this will give me P vertical and this will give me P horizontal. Is it clear now? So what is this P vertical? Let this be A point, this is B point, this is C point, this is D point, and this is E point. So when I take P vertical, it is equal to tau xy multiplied with the area BD into 1. And when I take P horizontal, it is tau xy multiplied with EB into 1. Because only I am taking this much. This is EBD. Is it clear now? So this is the element that I am taking, my dear friend. This is 1, and this is 1. So the area on which tau vertical is acting and the area on which this is P horizontal is acting. So these two will have two components, my dear friend. So one is P tangential, this is P normal, this angle is theta, and here you see that this is P normal and this is P tangential. So total sigma normal is equal to tau xy sin 2 theta after substituting all the values, and shear is equal to tau xy cos 2 theta. Is it clear now? Means this plane will be having a normal as tau xy sin 2 theta, and it will be having tau xy cos 2 theta. Is it clear now? These are the two planes. So similar as we have done the derivation for sigma x and sigma y, similarly you will do the derivation for this tau xy also. Now I will club all these three. My dear friends, and let's see what will be the resultant normal and tau for this. Is it clear? So when sigma x, sigma y and tau xy acting, so my dear friends, your sigma normal will become sigma x cos square theta because of sigma x, sigma y sine square theta because of sigma y plus tau xy sine 2 theta because of tau xy, and your shear will be equal to sigma x minus sigma y by 2 sine 2 theta because of sigma x and sigma y minus tau xy cos of 2 theta. So these are the two very important formulas, my dear friends, by which we can find out the normal and the shear stress on the plane P. So this will be your sigma normal and this will be your shear, and the inclination with respect to vertical is theta degree. So theta degree is with respect to vertical and tau is down the plane. So you have to remember these two formulas only. So at any angle you can get the value. At any angle you can get the value. Is it clear now? Now I will explain you the very good trick of drawing the Mohr circle where you can get the values of the principal stresses, my dear friends. So what is Mohr circle? Can anybody tell me? What do you mean by Mohr circle? What do you mean by Mohr circle, my dear friend? Mohr circle is a graphical method to find the principal stresses. Right? Since it is a graphical method, we should consider some x-axis, we should consider some y-axis, my dear friend. Keep in mind that your x-axis always represent the normal stress and y-axis always represent the shear stress, my dear friend. So this will be your plus sigma, this is plus tau, this is minus sigma, this is minus tau, my dear friend, and this is the point of origin. Is this clear? This is the point of origin. Why we take Mohr circle from its center point? So my dear friend, whatever value of the stresses to be taken, it should be taken from origin only, my dear friends. It should be taken from origin only, my dear friends. So I will tell you the best method or the easiest method where you will understand how to draw the Mohr circle, my dear friends. So I will consider this all sigma x, sigma y and tau xy as a biaxial problem. So let's see that the area on which the plane on which these are acting. So let this be P1 plane and this be P2 plane, my dear friends. So first I take plane P1. So when I take plane P1, what are acting on plane P1? So this is plane P1. So what is acting on plane P1? Sigma x is acting in x direction, that is tensile, and along with that you see that the shear is vertical, which will give an anti-clockwise rotation. Is it clear now? So the shear which is acting here called as tau yx or tau xy is giving you this. So can you tell me what are the coordinates of P1? It should be x comma y. Your x is sigma normal. So that will become plus sigma x comma minus anti-clockwise. So it will be plus tau xy. Since counterclockwise, so this is tensile, so positive, this is counterclockwise rotation, so positive. Is it clear now? So where is this point? This point will be from origin, this is sigma x, and somewhere here you get P1 point. So this point is called as P1, which is equal to sigma x comma tau xy, both are positive. Hence this point is in the first quadrant. Is it clear now? Hence this point is in first quadrant. Right. Very good evening, Rishikesh. And when I talk about the second plane, so this second plane, that is P2. When I talk about P2, you see that P2 is horizontal. P2 is horizontal. On horizontal plane, this is plane P2. On horizontal plane, you see that sigma y is acting, which is tensile, and along with that you see that the shear is giving a clockwise rotation. So your tau xy is giving a clockwise rotation. So your P2 point will become x comma y, which is equal to plus sigma y and minus tau xy. Is it okay? So where is this point? This point is, this is sigma y, and minus means downward. So here you get point P2. So this is the point where you get P2, which is equal to plus sigma y minus tau xy. So it will be in the fourth quadrant. So it is in fourth quadrant, and this one is in first quadrant. Is it clear now? Yes, you can take opposite also, Akhilesh. So you stick to the convention that you are taking. If you are taking clockwise positive, you take clockwise positive, anti-clockwise will be negative. So your P1 will come down and P2 will go up. Is it clear now? No need to worry about that. But anti-clockwise is positive every time. Is this clear? Right? Huh. So generally what happens on a rectangular element, the area associated with sigma x is less. So generally this is the problem. So the area associated with sigma x, so here sigma x is acting and the area is ax. Here sigma y is acting and the area is ay. So in general, since ax is less than ay, sigma x is greater than sigma y. Is it okay? So Imtiaz, generally we take in this way. Is this clear? Now what I will do here is, these two are the extreme points. These two are the extreme points. In the problem they are at 90 degree. So they are at 90 degree, means P1 and P2 are at 90 degree. So on the graphical plane they will be separated by 2 theta inclination, which is 180 degree. So if this is equal to theta, this angle is called as 2 theta. So your 2 theta will be equal to 180 degree, my dear friends. So P1 and P2 are separated by 180 degree inclination, and wherever it intersect x-axis, that is called as the center of the Mohr circle. Wherever this line intersect x-axis, that is called as center of the Mohr circle. So C as center, radius equal to CP1 or CP2, will draw a circle, and this circle is the circle Mohr circle for this problem. Is it okay now? This circle is the Mohr circle for this problem. Is this clear to all of you? So my dear friends, this point is sigma y, this point is sigma x. This is your P1, which is equal to sigma x comma tau xy, and this point is P2, which is equal to sigma x sigma y minus tau xy. Is it okay? Minus tau xy. So my dear friends, these two to be separated by a straight line. So join these two with a straight line, my dear friends, and wherever it intersect x-axis, that is called as the center of the Mohr circle. So this point is called as the center of the Mohr circle, and let this be A point, B point, C point, D point and E point. Is it clear? So our interest here is, if this is tau xy and this value is sigma x minus sigma y by 2. So this is called as the radius of the Mohr circle, which is equal to sigma x minus sigma y by 2 whole square. plus tau xy square. Is it clear now? See here, Venkatesh. Generally, your tau xy on this plane will give you vertical. So this tau xy on this plane P1 is giving an anti-clockwise rotation and counterclockwise is regarded as positive. And on this plane P2, this is giving a clockwise rotation. Which is regarded as negative. Is it clear now? So don't worry, whatever you want, you take it. But generally, anti-clockwise is regarded as positive, clockwise is regarded as negative. You do change that. So you take clockwise positive, counterclockwise minus. So your P1 will come in fourth quadrant and P2 will go up in the first quadrant. Is it clear, Venkatesh? Is this clear to all of you? Yes, very good, my dear friends. Come on, cheer up, yaar. Compulsory, we will expect 1 or 2 questions on this, my dear friends. Right. Thank you. Thank you, Venkatesh. So I will erase this once again. Right. So my dear friends, first question will be center of the Mohr circle. So what is the center of Mohr circle? Center of Mohr circle is equal to O to C, which is equal to OB plus BC, which is equal to sigma y plus sigma x minus sigma y by 2. Hence the answer comes out to be sigma x plus sigma y by 2. So my dear friend, average of the normal stress is always called as the center of the Mohr circle and it lies on x-axis. Very good, my dear friend. Thank you for your valuable comments. So my dear friends, are you enjoying the session? If you are really enjoying the session, my dear friend, please don't forget to share and subscribe this video. Also, don't forget to press the like button, my dear friends. And second is called as the radius of the Mohr circle. So how to draw the radius of the Mohr circle? It is equal to Cp1, which is equal to square root of sigma x minus sigma y by 2 whole square plus tau xy square. Is it clear? Plus tau xy square. Now my dear friends, let's see here. Now my dear friends, please see one small. So this is the point E where you see that tau is equal to 0, and this is the point A where you see that tau is equal to 0. So only on these two planes which are on x-axis, means A and E are the plane. A and E are on x-axis, where y is equal to 0 implies that tau is equal to 0, means the leftover stress is called as sigma 1, which is the maximum principal, and sigma 2 is called as a minimum principal, my dear friend. Is it clear? So this can also be written as sigma 1 minus sigma 2 by 2 is also called as the radius of the Mohr circle. My dear friend. Is this clear? And third is called as the maximum principal stress. Which I call it as sigma 1, which is equal to OE, can be written as OC plus radius. So very easily I can get the answer for this, which is equal to sigma x plus sigma y by 2 is the center of the Mohr circle, plus radius is equal to sigma x minus sigma y by 2 whole square. plus tau xy square. This we have taken yesterday at the start of the class, my dear friend. Is it clear now? Right. Thank you, Shankar. So, my dear friend, those who want to go for sleep, very happily you can go for sleep, have a sound sleep, and tomorrow morning once again you can listen the class when you are energetic. I am not asking you to be stressed, my dear friends. Is it clear now? It is for you, not for me, my dear friends. If somebody get a small benefit out of it, I am really happy. Okay, so don't take it otherwise. If you are getting sleep, very happily please go to sleep, have a sound sleep. Tomorrow also you can listen this class, don't worry about that, right? So those who are not getting sleep, for them you can listen here. So one is minimum principal stress. So your minimum principal stress is sigma 2, which is equal to OA, can be written as OC minus radius, which is equal to sigma x minus plus sigma y by 2 is center, minus square root of sigma x minus sigma y by 2 whole square plus tau xy square. Is it clear now? Yes, AC is the center of the Mohr circle. Yes, these are the questions that you remember, or directly draw the Mohr circle and take the values from the geometry of the circle, right? So from the geometry of circle you can directly take the answer, my dear friends. And the last one is very important, which is mostly asked, which is called as maximum shear stress. So when shear is maximum, this angle is 2 theta. So when 2 theta becomes 90 degree, when 2 theta becomes 90 degree and 2 theta becomes 270 degree. So this is 90 degree and this is 270 degree, and 270 degree means theta is equal to 45 degree and 135 degree. On these two planes you get maximum shear, tau max here, and one more value of tau max here, and this value is equal to tau max, which is equal to the radius of the Mohr circle, my dear friends, which can be written as sigma 1 minus sigma 2 by 2. Is this clear? It is OC. OC is the center of the Mohr circle. Imtiaz. OC is the center of the Mohr circle. Imtiaz. OC is the center of the Mohr circle. All the values should be taken from origin only. All the values should be taken from origin only. Thank you, Venkatesh. Is this clear? No, 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 no. These 45 and 135 are, these 45 and 135 are, right? 45 and 135 are shear planes. Shear planes. Is it clear now? Are shear planes. Are shear planes. And 2 theta is called as orientation of the principal plane. And 2 theta is called as orientation of principal planes. Anand, is it clear now? Oh, sorry. OC is center here. OC is center. Everywhere I have written OC only. From origin to center, C is the center of the Mohr circle. Shalini. From origin O value, 0 value to the center C is called as the center of the Mohr circle. Is this clear? Not from A to C. Not from A to C, my dear friend. OA is called as minimum principal stress. OB is called as sigma Y. OB is called as sigma Y. Yes, yes. Shear plane is 45 degree and 135 degree. Anand. Clear, Venkatesh? What do you want me to repeat? Is this clear to everybody? Is this clear? Venkatesh, you want me to repeat something? Right? So if this is okay, shall we proceed for some? Let me repeat this. So when I join this P1 with P2, I will be getting the center where it intersect x-axis. So keep in mind that the center of the Mohr circle always intersect at x-axis only, right? So this is called as 2 theta inclination, and this is sigma x minus sigma y by 2, and this is called as tau xy. So your radius of the Mohr circle will be sigma x minus sigma y by 2 whole square, adjacent square plus normal square. Is it clear now? So what is the radius of the Mohr circle? So the radius of the Mohr circle is equal to C to P1. This is C and this is P1. This is called as radius of the Mohr circle, which is equal to square root of sigma x minus sigma y by 2 whole square, that is adjacent square, plus normal square tau xy square. So this is adjacent value, this is normal value. So it is a right angle triangle, my dear friends. This is A, this is B. So this will be square root of A square plus B square. Is it clear, my dear friends? Imtiaz, Venkatesh. Right? Okay. So this is point number 2, and point number 1 is center of the Mohr circle. Center of Mohr circle. So what is the center of Mohr circle? Center of Mohr circle is equal to from origin to C, that is O to C, but I don't know that value, so I know only B value. I know B value which is given in the problem as sigma y. So this I will write down it as OB plus B to C. So what is B to C? Sigma x minus sigma y by 2 is B to C. So this will become sigma y is OB plus sigma x minus sigma y by 2. Hence, I will be getting the answer as sigma x plus sigma y by 2 is called as the center of the Mohr circle. Is center of the Mohr circle. And the point A and E are called as sigma 1 and sigma 2. So the third question will be maximum principal stress, which is denoted by sigma 1, which we call it as OE, can be written as OC plus radius. So which is equal to sigma x plus sigma y by 2 is OC, center from here plus radius from here. So square root of sigma x minus sigma y by 2 whole square plus tau xy square. Right? And minimum principal stress sigma 2 is equal to OA, which is equal to OC minus radius. One will be plus, one will be minus. And last will be maximum shear stress which is equal to tau max. So you will be getting tau max here and you will be getting tau max here. So one is complementary as I told you yesterday. So your tau max will be equal to the radius of the Mohr circle, which is equal to sigma 1 minus sigma 2 by 2, or this one. This is also radius. Is this clear? So let's proceed for the problems, my dear friends, and then we'll take a leave. So first question on the screen. if the prismatic bar is subjected to an axial tensile stress sigma, then the shear stress induced on the plane inclined at an angle theta with the axis will be. So what is the value of the shear stress on plane P? Tau on plane P. Means when a material is subjected to just only one sigma. So they are asking what is the value of shear on this plane. Very good, my dear friends. So on this oblique plane, you have got a normal stress which is equal to sigma cos square theta. E is called as sigma normal, and shear is down the plane which is equal to sigma upon 2 sine of 2 theta. So our question is this one, my dear friends. Hence the right answer to this question is A. Very good. Hence the right answer to this question is A. Very good, very good. Good going, my dear friends. Come on. In a two-dimensional stress analysis, if the state of stress at a point is shown in the figure where sigma x is 120, sigma is 120, so this is 120 MPa and this is equal to 70 MPa. Then sigma x and sigma y are. So what is our normal? Sigma x cos square theta, sigma y sin square theta plus tau xy plus tau xy sin 2 theta, right? So here only sigma x and sigma y are there and this angle is theta. So your sin theta will be becoming, sin theta is equal to BC divided by AC, which is equal to 3 by 5, and cos theta is equal to AB divided by AC, which is equal to 4 by 5. Don't find out theta and then proceed. In this problem, tau is up the plane. So this equation will become, the first equation will become 120 is equal to sigma x cos is 4 by 5 whole square plus sigma y 3 by 5 whole square plus 0 is equation number 1. And second equation is minus 70 is equal to sigma x minus sigma y by 2 sin 2 theta, right? So from this I can write down it as sigma x minus sigma y by 2 sin theta cos theta, 2 sin theta is 3 by 5 and cos theta is 4 by 5. This is equation number 2. Solving 1 and 2, we get sigma x and sigma y, my dear friends. B is wrong. Shubham, B is wrong. B is wrong. This is minus 70. Why? Because our equations are sigma normal and tau. Tau is down the plane. But in our question, tau is given up the plane. That is the reason we have taken minus. Yes, Aman Sharma, very good. So your sigma x will be 67.5 MPa and this is equal to 213.3 MPa. So whichever value is not given, my dear friends, you have to take it as 0 there. As tau xy is not given, take it 0. Is this clear? So let's proceed for the next question, my dear friends, on the screen. A metal block So a metal block of 100 mm square cross sectional area. So A is equal to 100 mm square and tensile load is 10 kilonewton. For the plane inclined at 30 degree. So theta is equal to 30 degree. Calculate the normal stress, shear stress and maximum shear stress. So your normal strain at theta degree at 30 degree, right? Only one direction strain. Your shear stress at 30 degree and your tau max. These are the three questions which are asked to you, my dear friends. So what is normal stress? Sigma x cos square theta. This is sigma x by 2 sin 2 theta. And this is maximum is just half of the normal. So what is sigma x? 10 into 10 to the power of 3 divided by 100. So this is equal to 100 MPa. So what is the answer here? So this is 75 MPa. This is how much? 43.3. And this is equal to 50 MPa. Is this clear? So here at sin 2 theta is equal to 1, you get tau max which is equal to sigma by 2. Very good, my dear friends. Next question on the screen. A shaft subjected to torsion experience a pure shear state of stress tau on the surface. The maximum principal stress on the surface is at 45 degree to the axis will have a value. So a material is subjected to pure shear. So what are the values of your plane 1 and plane 2? So this is plane 1, this is plane 2. So plane 1 is equal to 0 comma plus tau. This is 0 comma minus tau. So when I plot this, your plane 1 will be above this xy line, x line, and your plane 2 is here. So this is the center of the Mohr circle, and you will be getting a circle for the pure shear like this. So this value is your sigma 1, this value is your tau max, this value is your sigma 2, and this value is your tau max. So your sigma 1 is equal to plus tau, your sigma 2 is equal to minus tau, your tau max is equal to tau. So this is what the question asked to you. So out of these 4 options, which will give you tau? A option will give tau by root 2, B option is root 2 tau, C option is, this is cos square 45. So C will give you tau by 2 and D is giving you the answer tau, my dear friends. So the right answer to this question is D. There is no sigma x and sigma y, Imtiaz. Since no sigma x and sigma y, these values are 0. Imtiaz, is it clear? Yeah, Aman Sharma, what is your doubt? It is with respect to vertical we have taken and solved. So next question, my dear friends. A solid circular shaft is subjected to maximum shear stress of 140 MPa. Means your tau max is given as 140 MPa. The magnitude of the maximum normal stress developed on the shaft is, the magnitude of the maximum normal stress developed on the shaft is, the magnitude of the maximum normal stress developed on the shaft is, very good, my dear friend. Just now we have seen that when a material is subjected to 140 MPa, that is pure shear, like this. So your plane 1 is 0 comma plus 140 and your P2 is equal to 0 comma minus 140. So I will be getting a Mohr circle like this, where all the values are 140. Maximum principal is 140, maximum shear is 140, minimum principal is 140, shear is 140, maximum compressive is 140. Hence the answer is 140 MPa. So let's proceed for the next question, my dear friends, on the screen. Yes, it is pure shear. The figure shows the state of stress at a certain point in the stressed body. The magnitude of the normal stress in xy plane, xy direction are 100 MPa and 20 MPa respectively. Means your sigma x is equal to 100 and sigma y is equal to 20. Just one or two questions are left over, Yadav, don't worry. एक दो क्वेश्चन ही बचे हुए। D, C. D is wrong, my dear friends. You have to see the figure. It is compression in the figure, as shown in the figure. So sigma y क्या दिया हुआ है? Sigma y दिया हुआ है compression. So your tau max is equal to, or radius of the Mohr circle is equal to, radius of the Mohr circle is equal to sigma x minus sigma y by 2 whole square plus tau xy square. And tau xy is not given, which is equal to 0. So the answer will be sigma x minus sigma y by 2. So ये हो जाएगा आपका 100 minus of minus 20 divided by 2. Hence it will be 60 MPa, my dear friends. प्रथमेश 40 गलत है. वेंकटेश 40 is wrong. Akshay Mehta 40 is wrong. So the right answer to this question is 60. Right answer to this question is 60. Is it clear? Next question, my dear friend. If the principal stress in a plane stress problem are sigma 100, sigma 2 40, the magnitude of the maximum shear stress in MPa is sigma 100 दिया हुआ है, sigma 2 is given as 40. They are asking what is the value of tau max. This is last but one question, my dear friends. And after this only one question and we will take a leave. Thank you for your patience, my dear friends. I really appreciate. This shows your motivation, self motivated. ये गेट के लिए चल रही है. वेरी गुड श्याम किरण. शुभम हैज गिवन 30. अमन 30. सब लोग 30 दे रहे हैं, बट 30 गलत है. जनरली 30 करेक्ट होता है, बट यहां पर गलत है. जनरली 30 इज करेक्ट. Why? Because the radius of the Mohr circle is equal to sigma 1 minus sigma 2 by 2, which is equal to 30. But in this problem it is wrong because it is a plane stress problem. So we should know what is this plane stress. So plane stress क्या चीज है? Plane stress is a 3-dimension problem in which sigma 1 is given as 100, sigma 2 is given as 40, and sigma 3 is equal to 0 for plane stress. You should know this. Right? So my dear friends, when I plot this, यहाँ पर your sigma 1 100, here your sigma 2 40, and your sigma 3 is equal to 0. So I will be getting a Mohr circle. यहाँ पर एक मिलेगा जिसका tau max हो जाएगा. Tau max is equal to 100 minus 40 by 2, which is equal to 30. And you get one more circle. You get one more circle for which you get the answer as 40 minus 0 by 2. So one more tau max, which is equal to 20 MPa. And you get one more Mohr circle, which is equal to sigma 1 and sigma 3. You will get one more circle, my dear friend, and this is the tau max, which you get 100 minus 0 by 2. So radius maximum shear stress tau max is equal to the maximum of sigma 1 minus sigma 2 upon 2, sigma 2 minus sigma 3 by 2, or sigma 1 minus sigma 3 by 2. So maximum of 20, 30 and 50 The answer is 50 MPa, my dear friend. Is this clear? Is this clear? Is this clear to all of you? Those who have given 30. So a small mistake, my dear friend, a small mistake will give a wrong answer and there will be negative marking just because of the word plane stress. So we should know what is this plane stress, my dear friend. Is it clear now? MSST की जरूरत नहीं है, ये तीनों में से जो मैक्सिमम रहेगा वो रहेगा, राइट? नेक्स्ट क्वेश्चन, लास्ट क्वेश्चन माय डियर फ्रेंड्स. द मैक्सिमम एंड द मिनिमम प्रिंसिपल स्ट्रेस मींस सिग्मा 1 120 दिया हुआ है, सिग्मा 2 is given as 70 MPa, then the normal stress is given as 115. What is the value of the shear stress, my dear friend? क्लियर है? आखिरी क्वेश्चन, लास्ट क्वेश्चन माय डियर फ्रेंड्स. और समय चाहिए क्या? So यहाँ पर listen here, this is sigma 1 120, this is sigma 2 70. So this is the center of the Mohr circle. This is the center of the Mohr circle and this is the Mohr circle for this problem. This is your sigma 1, this is your sigma 2 and your center lies at what distance? So radius is equal to 120 minus 70 divided by 2, which is equal to 25. So 70 plus 25 is 95. Now our question is on plane P, if your sigma normal is 115, what is the value of shear? So if this is 115, what is this? So my dear friend, this distance you see that from here to here it is 115. So what is this distance? 115 minus 95. C to D distance. What is C to D distance? C to D distance is 115 minus 95 is 20 and your radius is 25. Your question is PD. So tau is equal to PD, which is equal to square root of 25 square minus 20 square and it comes out to be 15 MPa. Is the right answer to this question. So this is what is the question, which is equal to 25 square minus 20 square. Rishit Raj 69 is wrong. Aman 45.8 is wrong. Venkatesh 20 is wrong. 95 is wrong. The right answer to this question is 15 MPa, my dear friend. So Mohr circle will give answer very easily, my dear friends. So please try to solve this type of problems with just drawing the Mohr circle correctly which will give answer with minimum time, my dear friend, less than a minute also. Is this clear to all of you? Did you enjoy the session? Very good, very good. So my dear friends, tomorrow at 11 p.m. I will be taking the class of shear force and bending moment, my dear friend, which is one of the very important topic where all the students get confused. I can tell you within half a minute or 1 minute, you can get the value of the maximum bending moment in the beam. So I will tell you how fast you can get the value of the maximum bending moment in the beam. So that is what tomorrow at 11 p.m. my dear friends. Please share with your friends. Subscribe this video, my dear friends. If you really enjoyed this, press the like button, press the bell icon, my dear friends. So also on Gradeup Super app, please follow me at Rushi Joshi. So whatever classes I am taking on the app for you will be visible to you, my dear friends. 95 कैसा आया इम्तिहाज? यहां पर OC is this is A, this is C, this is B. So OC is equal to OA plus AC, which is equal to 70 plus 25 radius. So it will be 95. Imtiaz, is it clear? Yeah, because I will share the PDF. Don't worry. Thank you for your valuable comments, my dear friends. Don't forget to press the bell icon and share with your friends. So, my dear friends, Gradeup Super is such a platform where all your dreams will come true, my dear friends, such as your central government job through ESE, GATE, PSU jobs, MTech, MBA, MS, everything, my dear friend. So Gear Up and Rank Up are the course which are running for 2021, and Vision is the batch which is running for 2022, my dear friend, for ESE and the GATE mechanical aspirants, my dear friend. So you can see the topmost faculties in the industry are there on the slide. Along with me, Dheeraj Sardana sir, Ankit Joshi, Omkar sir, Chandrasekhar sir, Harshit Agrawal sir, Balaji sir are there to deal the subjects of their expertise. So my dear friends, I want you to be here. So definitely we at Gradeup, all the faculties are there to help you and see that you get a better rank, and we want you to be here, my dear friends. Gradeup Super will give an unlimited access to the structured live course and the mock test, my dear friends. 3 months of subscription will cost you 9,000, 12 months subscription will cost you 22,200, 18 months 30,600, and 24 months 36,000, my dear friends. Any doubt, you can just contact on this number. Yes, my dear friends, what is your doubt, Venkatesh? So my dear friend, please take care of yourself and your family members, but don't forget to be in tune with Gradeup Super, which will give an unlimited access to the structured live course and the mock test. Okay, so thank you, my dear friends, and good night. Have a sound sleep and get up with a very fresh mind. It will be there, Venkatesh. These classes will be there on the YouTube app, Gradeup Gate channel, my dear friend. Gradeup Gate channel.